Alright, so in this series of video, we'll talk about everything about metals, okay? And in over here right now, we'll start to talk about high strength, low alloy steel. Alright, take note that it's a high strength, low alloy (HSLA), and I'll talk about all these things in this video, specifically this one. Alright, and then subsequently we'll talk about all this stem form and data are just brands of the HSLA, and other type of metals, nickel, titanium, or enamel, steel, and certain case study we'll talk about. But nonetheless, we shall introduce you to the this type of metals and how it's made and advantage and disadvantages. Okay. Please take note that we are dealing on high strength low alloy in this scenario. Okay. So it's a micro alloy steel. Alright, it's not a chemical alloy steel. Chemical alloy steel is the conventional steel that we talk about. You mix something with something, you come up with something. Alright, it's more on chemical bond. Over here is more on the micro alloy steel. It's more on the micro structure. So you change the structure of the thing. So there is a difference in terms of that. Alright, so you change the structure to become high strength while you have a certain low alloy. Alright, low alloy I would believe is the amount of things you put in. So it's the amount of other chemicals other materials that you put in together with the particular metal in order to have certain stuff. Alright, so what's the difference from high strength low alloy to conventional steel is that they are not considered to be alloy steel in the normal sense because they are designed to meet specific mechanical properties rather than a chemical compositions. Alright, this is what I'm talking about, and it provides better mechanical properties and greater corrosion resistance, alright, than conventional carbon steel, which is the carbon alloy steels or things like that. Okay, and therefore this type of steel is a new type of thing coming out. Okay, and if you want to know more, you can actually type this type of high strength low alloy. You go to ASM International. It's a metal company, I think, and then you can go and search for it. Alright, there's a report on there which shows different materials like chromium, copper, etc. will enhance your HSLA steel in a different way. So they actually review the amount of stress, the amount of corrosions, the polite so-called the microstructures, etc. So the properties are all over here. So if you in the future you will need it, then you can just access through this thing. It's a very good thing. So over here, alright, after we know what is actually HSLA now, okay, please ignore this sentence because we are not studying ceramics. So in the case that if you want to study ceramics, then you can read it up. Alright, why the comparison between metal and ceramic is because ceramic itself has certain defects. Alright, and therefore sometimes metal is required. But nonetheless, if you want to know more, you can search it out for other ceramic stuff. I'll not talk about it over here. And this one I think you can read it yourself. And advanced metals for automotive, take note of these things like high strength steel, smart materials, rapid cooling material, and stainless steel. Alright, so what are all these things and why are all these things important? High strength steel, for example, alright, in terms of sheet, alright, because it provides better impact resistance if it's high strength, things like that. Or smart materials, for example, you can have one material but different properties or a lot of properties. So you mix here and there. That's why you have a different alloy. Okay, as for example, if you are this dude over here, alright, you just want the surface to have good high strength, but the below of it is ductile. So nonetheless, one good way is to coat it with a hardened stuff. Alright, you may preheat or change the microstructure and things like that. So these are all the things that you may want to take into considerations. Alright, and rapid cooling materials is because if you cool it very fast, then you will create a high strength structure because of the martensite austenite process. But nonetheless, rapid cooling also allows a shorter cycle time because you cool it instead of instead of slow cooling, you faster cool, or you will have more time to do other stuff. Alright, and stainless steel alloy is just stainless steel alloy lah. Okay, so 5 minutes I only talk about this type of things only. Is intro to metal and stuff. So let's talk about how it's being made. So so this type of so-called steel is made in terms of sheet metal. Alright, yeah, they come in a piece, a very thin sheet, and then they are preheated through a certain furnace. So maybe this is the furnace. So they preheat with a certain temperature. So it's more on the temperature sensitivity form. Alright, and it's actually called a controlled rolling process. Alright, so it's different from the conventional rolling process if you think about it. Alright, and the term itself, controlled rolling process, if you were to search Wikipedia, the actual term, am I recording? I'm recording, okay, sorry. So it's thermomechanical processing. Alright, the actual term is called this. Is a type of this type of processing which integrates controlled deformations. So you want to somewhat deform it, alright, and heat treating it. Alright, why do we want to control deformations? Because you are making it as a sheet. Alright, sometimes the metal comes with a form of ingot or pig metal, I think, I forget already, but nonetheless it comes in terms of one piece of stone, not one piece of stone but rather than one piece of something. Alright, so you want to form it as a sheet, so you need to press it. Alright, so along the pressing period you may also want to heat it. Alright, so it's mixing the heating and the pressing all together as one. Alright, it saves a lot of time and effort, alright, while also ensuring that it meets your, because normally when you somewhat so-called press this thing into a sheet of paper, or sorry, a sheet of thin metal, you may also want to preheat, you may also want to so-called slow heat or whatever type of heating to change the overall properties of the sheet. Alright, but nonetheless, if you were to mix the heating and the deforming together as one, then you are saving a lot of time and money as well. Okay, and therefore they came out with this type of thing. Different type of heat treating, alright, will give you different type of so-called grain structure. So we are looking at the grain structure. If you remember, we are talking about micro alloy. Previously we talked about it. Alright, it's micro alloy. It's not a chemical composition type of thing. Alright, so therefore be careful of that. So let's come back here, and therefore controlled rolling process is used to prevent, or inhibit is called prevent, undesirable recrystallization of grains during the hot rolling process. Alright, so during the hot rolling process or this conventional rolling process, you can change the crystallization of the thing, which is sometimes it create problems, and therefore controlled rolling process is a better one. Alright, so these are the compositions I will not go through. Alright, it's a low carbon one. So there will be a certain continuous annealing. Annealing is called slow cooling. So instead of fast cooling, you slow cooling it. Alright, at a certain temperature, elevated temperature, increasing temperature. Okay, to add toughness, remove stress, and whatever it is. Okay, and include micro alloying, etc. Okay, and therefore once they comes in a thin sheet like this, or a thin sheet of paper, alright, they may actually be rolled. Or normally this is the feeding machine, for example, the machine. So you feed the metal out. So over here there will be a certain thing over here to curl the sheet metal. So they will curl and curl and curl and curl and becomes a coil. Alright, a coil of metal. So this coil of metal will be go and sell or whatever things, or you want to use it to whatever applicable things that you may want to use. Alright, and this is how you do the thing, and this is how it's being made. So let's talk about the advantage and disadvantage now. Okay, so I'll not go through a lot of things over here. I'll just highlight these are the advantage. Okay, so I'll highlight a few things. For example, like consistency of the properties, because if you have a different grain structure, alright, because if you just take a look on this picture, alright, I don't know where, yeah, so this is a different grain structure, alright, different grain, alright, recrystallization. So over here you may have different properties. Maybe this part over here is a bit ductile, then over here this part is high strength, etc. So it is a bit hard to, or in other words, the materials, because the stress distribution is not good when the grain structure is not consistent. So sometimes different stress point over here and this point over here is different, and therefore it may create crack in between due to the difference in stresses or difference in temperature. And thermal talks about the thermal expansion, things like that. Alright, I anyhow bomb, but anyway, so at least you get the meaning of that. And as if you have a very fine grain controlled grain structure, consistent grain structure, the stress distribution will be very good. Alright, and next is the tight tolerance. Alright, what is tight tolerance? Is just a tolerance. For example, if you have maybe I have, this is a hole. Alright, I want the hole to be 5 mm. Okay, sometimes due to manufacturing things, alright, it may actually plus minus 0.01. Alright, so due to manufacturing problems, may talk about the materials. So different materials can allow different type of so-called settling uncertainties in there. So from this case, alright, this type of hot roll strips, controlled hot roll strips, alright, provide a better or tighter tolerance. So you have a more better tolerance, 0.0001. If you have more tighter tolerance, then you have 0.00001. Okay, hopefully this is pretty clear. And nonetheless, the coil weight flexibility. Alright, previously we say that it comes in a sheet of metal, and then you may want to roll it to like a toilet paper like that. Alright, so the coil weight depends on how many coil or how many times you want to coil it. Alright, because maybe if the manufacturer wants 1 kg, and then because you're the supplier so okay, 1 kg I coil it up, so I sell it at 1 kg, or maybe 50 SGD per kg, that of thing. So it's easier to calculate and so-called categorize the price, things like that. So it gives you a very good thing for the supplier side. So it's called a coil weight flexibility in this scenario, because you can control the weight. Alright, the coil is a coil that has a weight, and the weight can be controlled, and this is the meaning of that. Nonetheless, there will be limitations. Alright, for example, limited width of the strip, because it's going through a machine. Alright, this is the machine. It may press the metal over here, then you press already, then it may come out. So over here, this length is determined by the machine. Alright, the machine, if it's longer one, then you will have a longer sheet of metal. So this thing is talking about that. Okay, hopefully you're kind of clear. Yeah. And then difficult to galvanize. Right, galvanize is a coating, alright, as a protective layer of zinc. Alright, the zinc itself is to protect against corrosion. Alright, so galvanizing is this type of thing. Alright, so you want to coat it with zinc. Alright, so when you coat it with zinc, you sometimes use the method of electroplating. Alright, electroplating, if you remember in section, I forget which video already, give me a while. I think it's 9.14. Alright, talking about anodizing. Alright, in other words, it's talking about, let's say you have this tank over here, and then you have some solution. You sink your metal over here, you sink a certain catalyst. So a long time, the oxygen, or there's certain reaction occur. So some of the oxygen may comes to this metal over here, and then form with the layer this piece of metal. So it will form a oxide layer. So this oxide layer will prevent corrosion from happening. So this is one way of galvanizing, and this way is called electroplating. Okay, it's a very fast way of explanations. Hopefully it's clear. And then limited weldability, because one way is that I think it comes in a thin sheet, or it comes with a thin sheet. So therefore, trying to weld sheet by sheet is very tough. Alright, because over here, if you were to weld it at this point, alright, it's because of this interface over here, this area, cross-sectional area. Alright, if you want to weld this part, alright, this part over here may have a certain problems with it, because there's a different grain structure, because when you weld the welding part, because of heating and stuff, the grain structure may be very different, or it may be very big as compared to the grain structure over here, or very small. So as you can see, this welding part over here, if you were to weld two pieces, alright, this part over here will have a bit grains over here. So most probably due to this type of so-called inhomogeneous materials, because this part over here is more micro grains, or more defined. Over here then is a lot of big grains, so the stress distribution has changed, and therefore may affect the certain properties of the things. So there is a certain restriction in terms of engineering, in terms of strength, etc., or safety factor, and therefore thinking about that comes back to here, it has limited weldability because of the certain mechanical properties constraints, I believe. Alright. So there is one word called light gauge in the reading materials. Alright, so light gauge steel, alright, in terms it's talking about lightweight, or the gauge itself can be in terms of a volume. Okay, so it's a light volume type of things. And if you were to go to this type of things, it's a light gauge steel wall design. As you can see, they are formed in terms of sheet metal. Alright, so they are formed in terms of this type of columns. So for example, if you have this give me a moment. You have this piece of steel over here, alright, the controlled form, or HSLA steel. Alright, you may actually form it as this type of things. Alright, so you may create a structure. So this is some form of a light gauge, light gauge. So it's a lightweight type of metal, and then you can using this type of things, because it's hollow, or you can create this type of structures, as you can see all over here. So which is pretty cool. Alright, and yeah, so Scottsdale construction system, if you want to talk about the software, I think. Yeah, but nonetheless, there are more other stuff like coefficient of friction, etc., that I haven't mentioned, and it's advantage lah, okay, in case you don't know. Alright, and this new processing methods, alright, produce less scatter in the mechanical properties. Alright, the strength range from 300 to 1000 megapascal, and I'll not go on as much, okay, because I think this will touch on about the properties. Alright, because about this over here is quite a lot of stuff talking about it, so I will try to split the videos into two. But before going into the properties, I also want to talk about something more. Alright, hopefully it's within, maybe I should split it in the next video, alright, where we talk about how to apply in the automotive industries of so-called advanced metals. I think, yeah, next video lah. See you there.